Hi, everyone, and welcome to this talk State of LLM Function. I am Timothée Verdier. I am a senior developer in the machine learning team for Wolfram Research. And we will discuss here today all the features in the Wolfram language for programmatic access to the LLM. Here is the brief outline of the very generous program scheduled ahead. So first, the introduction of the main function in the Wolfram language to interact with LLM service provider, namely generate text with LLM synthesize and its asynchronous counterparts, LLM synthesize submits, generates rapid the generation as a pure function with LLM function, and something more interactive with a conversation you can carry on with chat object chat evaluates. Then we move to defining the working environment and all the LLM setting with LLM configuration, the object that you can pass in the LLM evaluator option. The two settings we will focus on being the prompts and the tool. And time allowing, I will tell you a bit about the future of connecting to LLMs, either with Wolfram LLM kits, local LLM evaluation, and underlying service connection framework. Right. So let's start with the main LLM function of the Wolfram language and LLM synthesize. So when you interact with an LLM, you basically put an input, an instruction in natural language, such as give me the name of the 3 famous physics Nobel Prizes, and you send that to the LLM, which then will generate completion. So this is called the prompt, and this is the LLM answer. As you can see, citing Albert Einstein, Marie Curie, and Richard Feynman as famous physics prize laureate nominees, right? And what's very interesting in terms of programming with LLM is that they are very good at figuring out implicit instruction, which are very classic in natural language, and you can quickly get something that is very productive. So using LLM synthesize for completion, complete the following sentence: the last Nobel Prize in physics is awarded to, I can hope to get few names, and researcher Agostini, Krautz, and Lullier, which is a Nobel Prize from 2023. That's also limitation from the LLM. They basically have the knowledge at the time they were trained. So we need an update here, but that's interesting. And don't forget that every time you evaluate prompts in LLM synthesize, you're likely to get a different answer because the LLM is a language model that is basically sampling a statistical distribution of possible completion for your prompts. So here again, another answer. And if you want to control better the return value, you may want to craft the prompt in order to corner the LLM in the space you want it to answer. So there is a table, and I added much more instruction to get the answer, such as just add the missing names, do not repeat sentences, answer to the best of the current knowledge, do not put explanation, and just complete the last Nobel Prize in physics is awarded to, and now it becomes reproducible. Again, those are pure strings. Yeah, so what we added in 14, what we just added in 14.2 is the fact that you can work asynchronously. You send the query and you let the LLM answer, yielding again a kernel for you to run some more computation like 2 + 2 here. But if you do things synchronously, the only way you can get the result and interact is basically using handler function and side effect. Here is how LLM synthesize submits let you do that. You have the option handler function, and for the events that LLM synthesize submit provide, you will basically give a function and what would do things with your results. Here, assigning completion text to your results when completion generating event is emitted. And so if I run this, I get a task object, and results should be assigned. Result value is set by this completion generated handler function. You see that we added a few cherry on the cake, like lexical. Basically, I don't specify handler function keys here, and lexically they are found that completion text must be provided to the handler function. So what can we do with that? We can, in this case, monitor the duration of the completion asynchronously, so things are dynamic here. If we populate with the content chunks that the LLM sends us, we can stream the LLM answer here as the task goes. But, well, it's quite quick, but here you see, again, this is basically being populated as the LLM answer. We can also send, just have the different queries be handled in parallel. So here is a list with 5 missing answers, and exactly the same as before, asking to complete the sentence with the names of the last Nobel Prizes in physics, as has been in the news recently. And every time for each iteration value position, I will just put completion text in the result list at this position. And as the LLM runs, basically, I see that every time the query arrives, I have the answer here. And this is asynchronous. That means that it could have been that answer number 3 arrived before answer number 2, depending on when the LLM answers. Also, starting in 14.1, the LLM service provided have combined model together to be able to handle image expression as prompt. So you can provide a picture to LLM synthesize, and if you are pointing to the right model, it basically has some vision abilities. It says that this image is a black cat, and you can also mix prompt together and ask for the LLM in natural language to count the numbers of animals in the image. So quite powerful with for a one-liner. Also, many times you want to actually have a function that you can use in different contexts, and that's what LLM function is for. It does exactly the same thing as LLM synthesize, but it doesn't evaluate directly. It just provides you with a function object. Here is a prompt, again, Nobel Prize in physics. And whenever you evaluate it, then you get the results we had before. And if what's at this point is a bit meh, what's the point using the function rather than LLM synthesize? And the answer is well, because of the function parameter, the function here, the default prompt interpretation in LLM function is string template instead of being just string. Whenever you put backticks here instead of physics, you get a function where the prompt is populated at runtime. So now you can pass parameter to your function and get the last Nobel Prize for peace. At least, given what we saw, this is probably the nominee in 2023. And icing on the cake, you can interpret on the fly the return of the LLM, providing an interpreter specification in your LLM function. And now, if you, oops, sorry for that, if you evaluate for the category biology, for the Nobel Prize in biology, the result will be interpreted as a delimited sequence of persons. And here you see that you have 2 nominee in biology, probably in 2023, provided by the LLM. So it's for you to decide to trust it, but they are definitely something you can start computing with computable values. Those are entities. And again, since 14.1, because you can have image passed to some LLM model, we allow that using template object in an LLM function. And you can use a template slot, any expression that is going to be passed to the LLM, but they support string and image for now. We can extend that later. And it's in one line, you are able to actually build this image caption function, telling you the list of objects present in the following image and returning a delimited sequence of string. You can see that it actually found out monitor, keyboard, mouse, notebooks, high heels, shoes, and so on. So indeed, quite powerful. Now, chat evaluate and chat evaluate submit are the 2 functions that let you have basically have interaction with the LLM as a conversation that you can carry on with. So it starts with a chat object with the first argument being the prompt for the LLM part, which is pass model permitting as a system message. In this case, to talk like a member of the Nobel Prize Committee. And you then have a chat object that you can use to start the conversation. And again, it basically supports different type of input, including images and text. So you can start a conversation with what's on the picture for the domestic cat that you've seen here, and will appear in the message grid. And the LLM output will respect the talk like a member of the Nobel Prize Committee prompt that you supplied in the chat object at the beginning. And indeed, you can continue the conversation, like asking whether this Nobel Prize board member would support the first or the second cat, and get the answer here. So yeah, basically multimodal support for all the LLM functions starting in 14.1. Now, also starting in 14.2, next version, we extended chat evaluates to chat submit for the asynchronous function. And again, taking the chat object we had before, we can see the message grid being the chat object being populated. There is an extra handler function goes to pure function syntax for basically any event. Look at the chat object and set it to live results. And if I run this, then I generate a chat object, and we can see, just like in the chat book, for those who are familiar with, that this is populated live. And interestingly, if we provide the correct names, Hopfield and Hinton for this year, we can see what the LLM produces as an announcement summary. And it's quite similar to what we actually had. Groundbreaking contribution to the field of artificial intelligence, neural networks, understanding of complex physical system. So that's not that bad, in my opinion. Right. So now that we saw the different function that can be used to interact with LLM, the main ones at least in the Wolfram language, let's look in more detail in how we define precisely the working environments and how we specify settings for the LLM. First thing is that you can wrap all the settings for your LLM interaction in an LLM configuration object, and which will format as nicely as an object here, such as with targeting a given connection, LLM connection, changing service with setting the name, and also deciding on the sampling temperature to generate the answer. The larger the temperature, the more erratic the generation, also the more creative it will be, and limit the number of tokens. For instance, when you pay by token, you might be interested by this. And now that you have a new configuration, you can pass it in LLM evaluator option for any of those functions we saw, and have a different result and behavior. So now we are talking to Claude 3.5 sonnets from Anthropic, and it seems that LLM doesn't agree with the fact that mathematics has been added as a Nobel Prize category. And if you want to set those value globally, you can just use the $LLM evaluator and set it to the value to have all the LLM functions pointing to the defaults of your that you prefer. So one of the most important parts of the LLM configuration setting is the prompt. Basically, it's the instruction we already saw in previous slides, but those are passed as system instruction and sets the behavior of the LLM for the rest of the interaction. And you can, by passing a prompt, you can basically detangle the instruction to how the LLM should behave and your input. And you see, if I use LLM synthesize with question about what to do today, laser, and activities, it would say, well, you know, depends, and a few possibilities. And if I'm passing a prompt that says, basically, talk to me as a 5-year-old boy, the answer would be completely different. And of course, those prompts can be combined in a list. Yeah, fun things to do today, you know, drawing pictures and so on. And you can also alter this behavior by also instructing to answer all questions in Spanish, and same Spanish 5 years old. So this lets you pass configuration to define LLM behavior inside the LLM configuration object. Another addition an addition to this prompt setting in 14.1 is the fact that you can now generate the prompt on the fly based on information from the runtime information, such as the time at which you are actually running the query, some local information about your position at the time you run it. And this is done through prompt generator. And you can also access information about the inputs. So if I provide a date and place to the same question of what I can do today, OpenAI will basically greet me by my name and figure out that I'm in, in Paris. That's what I set in geolocation. And so give me more precise direction about where I can, which museum I could visit. And that's already a very tailored answer. But the main reason for designing LLM prompt generator is retrieval augmented generation, so-called RAG, which is one of the most interesting LLM interaction you can have. And there is a dedicated talk for that. So please go to the Semantic Search and RAG on Friday with Giulio Alessandrini to know more about it. Also, another thing is that you can, LLM can create, if you provide tools, so function to run locally on your computer, and that the LLM can query on-demand answer to those tools and get information from you, so information you control. And that also completely changed the actual output you get from the LLM. So let's get the prompt generator telling the LLMs that I'm the current time and that I'm in a place named Paris. And let's provide it two other tools. One which is called thermometer, and which description is that it gives a daily temperature. And it takes two inputs, one called dates, which is a date time or date type, and one called where, which is a location. And then it runs this function locally on my computer. If the LLM asks for it, it runs weather forecast data on my position, well, the position the LLM asked, and on the day that the date points to. And another tool called rain gauge that does the same for the total precipitation. And let's look at what the LLM is going to say about my query regarding what to do today. So those format as prompt generator, LLM tool, and I can provide it. Let's have a dynamic variable showing to show the results, and let's ask then the LLM providing the prompt to say hi and information about me, and the tools thermometer and rain gauge. This is going to be live, so I need a handler function says whatever assign chat object result to live result number 3, which is here, and let's look at it. So you see that the automatically definition on how to call the tool, and it's a bit too quick for us there. That how to call the tool and how to pass the information is provided to the LLM. Says, hello, Timothy, let's look into the weather in Paris to help you plan your activities. And the tool is going to, and so it's asking for thermometer today in Paris and rain gauge, and it gets those two results here. And you might have caught that basically all these interaction happens as strings. It's a text start tool call, end tool call, and this is then parsed internally, and this is returned as an answer and transformed back to text to be sent to the LLM. So something that service provider also added is the ability to basically use their own API interface to pass those tool call and make them much more reliable and efficient. So starting 14.1, if you say tool method goes to service method, so service here, then you will have the same interaction will look different. Whoops. The same interactions, sorry for that, will look different because instead of using texts and parse it, it's going to directly communicate with whatever formats the API is requesting, and it can pass two tool calls at the same time, which are parsed much quickly, and then you get the LLM answer with also much fewer tokens. If we look at the results usage here, but we didn't actually. It's like 500 tokens total, and it was probably a few thousand previously for the same answer. Okay, so this property message grid lets you just have the nice formatting of the message grid without all the chat objects, so makes it much more lightweight for the front end to typeset, and it's new in 14.2. The rest so those are nice tool formatting that came in 14.1. Right. We have 5 more minutes, so again, little teaser for semantic search and RAG. This Friday, 9 to 9:30 Central. Let's go there if you want to hear about retrieval augmented generation, vector database, and semantic search. Let's just give you a peek into the future of the LLM connection. All you've seen so far in this demo is basically connecting to third-party service providers such as OpenAI and Anthropic, as far as this presentation was concerned. But we have been working hard to have most prominent service provider ready to use out of the box, enriching the service connection system. And we also will start to provide a direct Wolfram LLM called Wolfram LLM Kits, where you basically don't need to subscribe to a third-party service provider, but you can ask Wolfram to basically provide you the LLM services. And also, if you have big computers and GPUs, you might be interested to point to a local LLM. We want it to be easy too. So here, so Wolfram LLM Kit, it's going to be very, very soon. You don't need external accounts. Wolfram in charge of everything. Service connection, you can access Anthropic API with chats and I probably a bit this this is new build, so here's but let's try whether OpenAI is recognized. Yeah, you see, basically we have this layer of formatting for any connected service that can be run to service and execute, and this is just the formatted raw content from OpenAI. If you want to build your own LLM synthesize on top of it, you have access to the very basic. And here is a list of all the services for which we added support in 14.1, updated in 14.2. And this is what it will look like shortly to run a local model. In LLM synthesis, you basically say local evaluator in your LLM configuration, and pass the path to the LLM file that you need to load in order to get your LLM. This is using LlamaLink, and you can find plenty of those files either on the internet or hosted in the net repository, or from net repository. And here we are, I think, ready for a few questions, but this presentation is not over.